All right, today we're going to pull back the curtain on some hidden math, the kind of stuff that's secretly running your day, from how you shop to how you travel. Let's get right into it. So let me ask you this. A shopping trip, your commute, a big project at work, what could they possibly have in common? They seem totally different, right? Well, there's a secret thread connecting them all.
And that's it, right there, proportion. It's a super powerful but really simple idea that explains how things are related to each other. And trust me, once you see it, you'll start seeing it absolutely everywhere.
Okay, first up, let's talk about things that are in sync, things that move together. This is where we meet our first concept, direct proportion. It's pretty much what it sounds like. You have two things that are basically best friends. When one of them goes up, the other goes up. When one goes down, the other goes down too. They stick together no matter what. Here's a super simple way to think about it. Buying sugar, the more sugar you buy, the more it's going to cost. If you double the amount of sugar, you're going to double the cost. They move in perfect sync. Now, there's a little bit of math behind this friendship. The formula is x divided by y equals k. And that k is just a constant. It's like the magic number that locks these two values together, making sure their ratio never changes. So how do we actually use this? Well, let's try a problem. A car drives 14 kilometers in 25 minutes. We want to know how far it can go in 5 hours, which is 300 minutes. Since the ratio is constant, we just set it up. 14 over 25 must be the same as our mystery distance, x, over 300. You do a little cross multiplication, and boom, the answer is 168 kilometers. Easy, right? But, not everything moves together. What about things that have the opposite relationship? For that, we need to hop on what I like to call the proportional seesaw and meet our second concept, inverse proportion. The whole idea here is that these two quantities move in opposite directions. Just like on a seesaw, if one side goes up, the other side has to come down. That's the heart of inverse proportion. Just think about driving your car. The faster you go, the less time it takes to get to your destination. As your speed goes up, your travel time goes down. One increases, the other decreases. It's a perfect seesaw in action. And the rule for this seesaw is a little different. Instead of dividing the two things, we multiply them. So here, x times y equals k. This means their product is the constant, the fixed number that keeps them perfectly balanced. Let's see how this one works. If 6 workers take 12 days to build a wall, their product is 6 times 12, which is 72. That's our magic number, our k. So if we only have 4 workers, their product still has to be 72. 4 times some number of days, y, equals 72. A quick division tells us it's going to take 18 days. Makes sense, right? Fewer workers means more time. Okay, so we've met both of our main players. Now it's time to put them head-to-head in the ultimate face-off, just to make sure we've got the difference locked in. Here's the whole thing in a nutshell. Direct proportion, they move together, and their ratio is what stays constant. Inverse proportion, they move opposite, and their product stays constant. That is the key difference you need to remember. All right, quick quiz time. Let's see what you've got. You hire more people to finish a project. Does the time it takes to get it done increase or decrease? Yes, it decreases. More hands on deck means less time on the clock. You just nailed an inverse proportion. Okay, how about this one? You're on a road trip. The more kilometers you drive, does the amount of gas you've used go up or down? Of course, it goes up. More distance means you burn more fuel. The two things increase together. That is a perfect example of a direct proportion. Nicely done. All right, let's try a trickier one together. So, a car trip takes 10 hours at 48 kilometers an hour. How much faster do we need to go to make the trip in just 8 hours? First, what's the relationship? Speed versus time is inverse. So we know their product is constant. 10 times 48 gives us 480. That product has to stay the same. So 8 hours times our new speed, x, must also equal 480. That means our new speed has to be 60 kilometers per hour. But wait, the question asks how much faster we need to go. So we just find the difference. 60 minus 48 is 12 kilometers per hour faster. So why are we even bothering with all this? Is it just for a math test? Not at all. This is a fundamental idea that you'll use everywhere, from the classroom to your career. Seriously, think of this as a building block.
getting a good handle on proportions, is what sets you up to tackle much more complex stuff later on in math and science. And this stuff leads to some really cool careers. Engineers, data analysts, economists, people working in logistics, they're all using the logic of proportion every single day. This is a real-world skill for sure. So now that you're practically an expert, I've got one final challenge to really put your new skills to the test. Okay, this one's a bit of a brain teaser. A team of 5 works for 5 days, and then the team gets bigger when 3 more people join. How does that change things? How many total days will it take to finish the job? This one pulls together everything we've talked about. So, think you can solve it? Give it a try.